Okay, we're flying with our lessons here. We are in Chapter 6, Linear Relations, looking at linear equations, and we've got to Lesson 5, so we're starting to graph them. So, depending on when you're watching this video, this may or may not actually be what minimum wage is at the moment. I think it's actually changed. I think it's higher than $9.75 now. We'll use $9.75. Just for our example, but it might change. It's probably higher. Just so you know, my first job, minimum wage, was like $6.25. So $9.75 is like $1 million by comparison. So, anyways, Mr. Carlos has a part-time job working at Home Depot. He makes $9.75 an hour. His earnings, which we're going to use the letter E for, can be modeled by the equation E equals 9.75 times T. So earnings equals 9.75 times T, and T is the number of hours that he's worked, so time in hours. So we're going to create a table to show the amount of hours compared to the earnings. So first we need to figure out what is independent, what's dependent. Well, the time happens no matter what, so his time in hours is going to be the independent variable. And so that means his earnings, E, is the dependent variable, so the earnings depend on the amount of time that he works. So it's always good, I think, to include a time of 0. So if he works 0 hours, how much is he going to make? Well, 9.75 times 0, he's going to make no money. So we'll fill it in for 1, 2, 3, and let's do 10 hours, okay? So if he works 1 hour, he's going to make 1 times 9.75, so 9.75. If he works 2 hours, he's going to work 2 times that, so 19.50. If he works 3 hours, 3 times 9.75, we're going to get 29.25. And if he works 10 hours, 10 times 9.75 is going to give us 97.50. So just to give us a little bit more range in our data, I know that the graph that you have might be a little bit light, so you might need a sticky note graph for this, or if you want to do it on some large graph paper and just staple it to your notes, that's fine too. So we are going to graph the coordinates on a graph. We're going to make a graph, a line graph. So we need to figure out what goes on each axis. So what goes on the horizontal, what goes on the vertical. So the horizontal axis, so what is usually what we say is our x-axis, is always our independent variable. And so in this case, our independent variable is time in hours. And so then our vertical axis is the dependent variable, and that is earnings. So we need to make a scale, 0. So let's have 1 hour, 2 hours, 3, 4. Okay, you could pick a different scale, but there's no point squishing your data together. Then we need to figure out, well, what's a good amount to go up by? Because it's going up by 9.75. Like, that's not an easy one to make. So maybe I'm going to say every second line is $10. And please note that I jumped 2 lines at the start, right? I skipped 2 boxes. If I only skipped 1 box, I would say from 0 to 10 is 1 box. So I need to make sure that I'm consistent. So I'm always going up by the same number. Okay, so now we're going to plot them. So our first point is 0, 0. So at 0, 0, I'm going to make a dot. My second point is at 1 and 9.75. So 1 and 9.75 is going to be just under $10. 2 and 19.50, so go to the 2 and 19.50, that's going to be under 20, but a little bit more under, so like that. We're kind of estimating a little bit, right? 3 and 29.50, that's just under 30. cetera, et cetera, et cetera. I hope you notice that it's making a straight line. If we go to 10, and we had 97.50, so 10, 95, 97.50 should be up there. So I'm going to grab a ruler, and we're going to connect the dots. Okay, and I'm actually going to put, let's do a line with an arrow, right? Because this could keep going. Potentially he could work more than 10 hours, I hope. Okay, so there's our line. There. Okay, it's beautiful. So based on our graph, what might he make after working 11 hours? So if you notice our graph only goes to 10 hours, we would need to go past our graph. So because we don't have our graph, let's use our equation. E equals 9.75 times T. And so this is telling us that T equals 11 hours. So E equals 9.75 times 11. So his earnings are going to be $106.25. Okay? And so if we were going to use our graph, this is where we would have to, we would either have had to extrapolate from our graph because we were going beyond our data set, but using our equation, I hope you remember from the last lesson, is the best way to find an exact value. So on the graph, what would he make if he worked 5.5 hours? So we could interpolate.
Call again to contact the office, please.
Oh, that's me. Hang on, I'll be back. Okay, I'm back. It's Mr. Valenzuela. He might interrupt us again in a minute or two. Let's see what happens. So we might interpolate to figure out how much he worked if he worked 5.5 hours. So we can do that. But then we're going to actually use our equation because that's a more exact value. So if we go back up, so 5.5 hours, that's going to be halfway between 5 and 6. I'm going to grab a ruler. We're going to trace our way up. Let's grab a dotted line. Okay, so we're going to trace our way up. So that way we can interpolate. Mr. Valenzuela just stole the Puno tiles, just in case you were wondering. Not all of them, don't worry, just some. Okay, we're interpolating 5.5 hours, approximately how much money is that? So trace it up. It's going to be, let's say maybe 52. Seriously, teachers, enough with announcements. But we're going to use our equation just to kind of double check. So E equals 9.75 times T. So E equals 9.75 times 5.5, and I'm just going to, I don't have that calculated. I'm going to write that one down. Oops. So I get, oh, look at how good we were, okay? 53.625, that's pretty close. So in money, right, because money never has that kind of decimals. 53.63. It's not horrible. It's a good paycheck. 5.5 hours. That's a nice little Saturday. Okay, so it says create the table of values for the following linear equations. So again, we're thinking independent, dependent. Independent is always going first, and then dependent is always going second. What I want you to keep in mind is that sometimes we switch up x and y, but we always write our equation in terms of the dependent. Okay, so if it's y equals, that's our dependent. If it's x equals, x is dependent. But we have it in y equals, so y is dependent. So pick any values you want. You can pick them in order or not. I would pick values that are actually on the graph you're given. So if you notice the graph you're given has x values that are only even numbers, pick those even numbers, okay? So let's go positive 20, let's go positive 5, let's go 0, 0 is always nice to have, let's go negative 10 and negative 15. So we should get a good What am I doing? I'm looking on the wrong values. I'm looking at our y-axis. All these interruptions have frazzled me. 0, 2, 4. I don't care which ones you pick. Pick a range of them, okay? And then we're going to graph them. So we're going to follow our pattern. So to figure out what happens at -10, we're going to go -10 times 2, -20. -6 times 2, -12. 2 times 0, 0. 2 times 2, 4. And 2 times 4, 8. So these are my coordinate pairs. I would suggest writing them out as coordinates just to help you get in the habit and recognize your coordinate pairs, okay? So we're going to graph them. -10, -20. -6, -12. So I'm going to have to kind of estimate that one a little bit. 0 and 0, don't have to estimate that one. 2 and 4. And then 4 and 8. So something like that, okay? So when you graph it, oops, whoa. When you graph it, and so our points are pretty close on the line. I estimated a little bit off there, but that's okay. Okay, so you're going to make the table for the next one. Remember, independent, dependent. So I'm going to show you what the graph should look like, just so you have an idea. I'm not going to complete the tables for you for B and C, because I want you to do these on your own, but I do want you to get a sense of if you feel like you've done it right or not. Okay, so for B, okay, so your second graph, y equals 2x minus 5. So it should look something like that. So your constant is -5, so it's going through -5, and it's increasing because it's a positive. Looking at C, our constant is +1, so we should be going through +1, and -3, so it's a negative multiplier, so it should be a decreasing pattern. So it should look something like that, okay? So just so you have an idea of what it should look like. But I will be checking that you have your tables filled in as well as your graphs done for tomorrow.